So hi everyone, my name is Mike. As you can see over here, I consider myself a breaker of things, but not necessarily breaking production code, more breaking concepts, breaking old ideas, and breaking comfort zones primarily. I'm currently doing that as a consulting software engineer at ING. This story is not about ING, it's actually about bol.com. And you can see some interesting facts about me, most important of which is probably my Twitter handle, which you can use during or after the talk if you want to reach out with some questions. So, as I said, this is a story about bol.com, and it's a story about an application that we classified as a beast and how we dealt with it, and basically the journey of taming that beast and turning it more into a pet, which we can play with. To give you a bit more context about what we're going to be talking about, I'm going to give you a bit of an idea where bol.com stands, where it comes from. Then I'll give you our definition of a beast. After that, I'll share with you what were the options that we had to deal with that beast. And finally, how we did the taming process and what are the lessons that we learned along the way. So I'm not going to ask who doesn't know who bol.com is. Instead, I probably should ask how many people here are from bol.com. And okay, well, it's less than expected. How many people have worked with the web shop of bol.com? Yeah, well, I hope that you'll find this interesting if you don't know it already. For the rest, I guess you know, bol.com is a company founded around 18 years ago. And last time I checked, which was around a year ago, it was around 1,500 people. I'm not sure if that's probably growing right now. And back then we had around 500 engineers comprising the IT department. And it has been growing ever since. So the journey is from a, let's say, continuous delivery point of view. Back when the company started, this is more or less a guess. There was one application which it had its one deployment, and that was pretty much it. But as the application grew, the release process became a little bit more streamlined. So there was still one big application, but it was scheduled to run to be deployed once every 4 weeks. Later, bol.com adopted service-oriented architecture, enabling the teams to be more agile, to be more in control of their services. But still, there was one deployment, started breaking up the monolith, but still the release cycle was into once every 4 weeks. And later on, even further on, around 2 years ago, the landscape looked a little bit more like this, where the teams could independently deploy their services, and this basically enabled a more agile way of working within the company. So when this was the case, everyone was happy, right? Engineers are happy, product owners are happy, everyone's happy. So how did the company end up in a state where anything needs taming? Well, sadly, some applications were still stuck in the past. And that was mainly due to their size and nature. And one of those applications was the bol.com web shop, which is essentially the money-making machine of the company. The only improvement it had seen release-wise in all those years was that it was deployed once every 2 weeks instead of the previous 1 monthly cycle. So why did a company that embraces agile principles keeps one of its most valuable application in a not so agile state? And the answer is that back then that thing was a beast. So what is our definition of a beast? It's a large application which is actively developed by a lot of people, but no one really knows all the ins and outs of it. And there are parts which are basically not known to everyone. And of course that's an overstatement, but we really wanted to put a lot of pressure on the issue. As I mentioned, the bol.com web shop was a large monolith. It was built on a framework which was not designed for the scale that bol.com has right now, which resulted in having a lot of not necessarily very well tested and not very well documented hacks, basically rendering it a legacy system. On top of that, it was simply unmanageable. Not because no one wanted to deal with it, but because we didn't have the right tools. And any single person that tried to manage the application would basically struggle, mostly because, to give you a bit of context, for a span of 30 days, around 70 engineers had committed over 900 commits when we started. And any single person that would manage this felt a little bit like this, and eventually just gave up. And this is the state that we're in. So, I don't want you guys to get me wrong. During those years, there were a lot of engineers that were actively working on the project, actively taking pieces out of it, and basically working actively on refactoring the monolith and breaking it into pieces. But the slow release process, the slow cycle that we had, was basically making this process really tedious. Mostly because it was creating those mini waterfalls where everyone was trying to push everything in, and it was really hard to get the right changes very well tested, very well refined. So it was becoming a bit frustrating if you want to make a bigger change on the web shop. So the question that we had is, why don't we kill it all together, right? Everyone's saying monolith nowadays. Monoliths. And the answer to that is that simply we couldn't. Mostly because, as I mentioned, this is the most valuable application for the company. Which means that you either have to stop adding new features if you want to rebuild it, or if you want to rebuild it and continue adding new features, you would have to add those new features both to the legacy system and the new system, effectively making this shooting at a moving target and reducing the chances of success. So we knew we couldn't kill it, so we decided to tame it. And for us, to tame it was basically to be able to change it at a fast and stable pace. We had the expertise, we had the knowledge to deal with the monolith, but what we needed is that really, really fast feedback cycle on whether or not the changes that we do are the right ones. Whether or not the things that we're adding are actually fixing things or breaking other things. And in essence, we basically needed continuous delivery. And it sounded like a natural next step because most of the applications within Bol.com actually have continuous delivery in their life cycle. But we quickly realized that the larger the project is, the harder it becomes. Well, maybe considering the name of the meetup, probably most of you know that the larger the project is and the more complex it is, the harder it is to implement continuous delivery effectively in it. Before I go any further, I just want to mention that by continuous delivery, I'm referring to the term, the definition by Martin Fowler, which is actually different but often mistaken with continuous deployment. The main difference is, of course, that with continuous deployment, all the steps, including deployment to production, are automated, whereas in continuous delivery, that last step of deployment to production is still scheduled manually. Now, we wanted to adopt continuous delivery on this very large monolith, and what's the first thing that anyone does when they don't know something? They start looking into Google. And when I first started searching for issues with CD, I got a lot of hits about compact discs, so it wasn't very effective. But then I upped my Google full and actually found a really awesome paper which identifies 40 continuous delivery adoption issues, which is, for me at least, was a striking difference compared to all the articles I found, because most of the articles that you find on the internet about continuous delivery are about how you should, like techniques about adopting it. This was the first article that I found which was actually dealing with the issues that you might encounter while adopting it. The problem for us is that this was published 2 months after we started, so we didn't have the option to basically use it. But retroactively, it would have been an invaluable source of information. And if you ever if you ever struggle with adopting continuous delivery, I highly recommend reading the paper, because what we had to do instead was meet up with a lot of people, spend a lot of time with. I have the link in my at the end in the references, so I'll share the slides. You'll be able to see the paper. But what I was saying is that we met with a lot of people, basically all the teams that were working on the web shop, gathered all their requirements, and retroactively, we would have seen all of those requirements within this paper. As I mentioned, it identifies around, I think, 40 continuous adoption problems, summarizes them in 7 groups. But out of all the meetings that we had, I think we have around 11 that were relevant to us, and I'd like to focus on them for now. The first issue that we encountered almost immediately and was predominant in almost all the meetings that we had was that our tests were flaky. So there were a lot of cases where people would simply not look at the test results because they said, yeah, I don't believe it. Like, it could, or if the tests were read, they would just say, yeah, just rerun it, which I think is a common theme in the industry. And the worst case was actually teams that would, every 2 weeks before the release, they would manually go and verify whether everything within their domain is working properly, which can be a little problem if you're striving to deploy a little bit more frequently. So basically you would have those kind of people non-stop verifying changes. So in order to solve this, we decided to take a radical approach and just start from a clean slate. We created a brand new test suite, which in the beginning had only 7 tests covering the very critical functionality, and we started expanding it with all the functionality that we considered really important. And well, all the functionality is important, but we started expanding it to cover as much of the functionality as we can, on the premise that every test which is in this suite should be stable. So if you had a flaky test, we'll take it out. And if you have an issue with your part of your system, well, basically you have to deal with it, and you would have to write the test. And the result was actually pretty stunning, because having that binary feedback whether your release is good, is okay or not, gives you a lot of confidence on whether or not you can move forward, and actually could set the grounds for continuous deployments, because if everything's okay, you can just simply roll the deployment. Another thing that we saw happening is that team started collaborating a lot more, because some people had the knowledge on how to fix the flaky tests, and they started helping other people fix their flaky tests, which set the grounds for another issue that we had with the company, which was the fact that people consider it a little bit of a no man's land. The fact that the web shop had so many layers and had been worked on for so many years basically made people have a little bit of a special attitude towards it. And you could see teams that would adhere to very high standards when they're working on their own services, but whenever they were working on the web shop, they were inclined to sort of take shortcuts, make workarounds, maybe a hack over here. Nobody would notice. It's such a big code base anyways. And for me, that's a very good example of the broken windows theory, because I'm not sure how many are familiar with it, but in short, it states that if you have a building or a car, and all the windows are intact, people are going to be more inclined to keep it that way. But if you have one broken window, people are going to be inclined to break more. So if your code base sucks, translates the code very well. If your code base sucks, people are more inclined to, add sucky code. That doesn't mean that they're bad developers. It's just that they adhere to the standard which is in the system. But yes, the broken windows here. But Actually, with the focus on the tests, people started collaborating a lot more, and they started, and that quickly expanded to other areas of the web shop, not just the texts. And that collaboration actually brought a lot of people together, and if there was an issue with one part of the system, people knew who to look for, who knew who to contact, which actually started building a better foundation for the web shop, and actually started making people started having a lot higher standards for the project in all in all, which eventually resulted in a lot better quality of the code, and yeah, basically people having better standards for the web shop. The next problem that we had was, this is something that I've experienced pretty much in every company that, or at least has been a discussion in every company that I've been in, and that's the branching strategy. Because a poor branching strategy would lead to a lot of merge conflicts, which of course causes your work process to be slower. And in our case, having that bi-weekly process resulted in some teams to work for 2 weeks on their own branch. And then when the release was being prepared, they would push those 2 weeks of work into the master branch. And that's okay if one team does it, right? I mean, it's not great, but it's workable. Now imagine 3 or 4 or 5 teams doing that, all the while other people adding more changes. It resulted sometimes in days or even weeks of delays, because it was turning into a little hell. All those merge conflicts, people merging them without having the proper context, resulting in breaking other people's code. It's like, it's a mess. The way we fixed it is by introducing a common branching strategy within all the teams that were working on the web shop, and it's essentially having a feature branch which you work on. Once you're done with your feature, you merge it back into master. And something that helped us a lot in that is, basically we Dockerized the web shop and integrated it with a internal tool called Mayfly. And I'll give a disclaimer, as far as I know, Mayfly is dying, so I think everyone would like the concept, but don't get too excited. Essentially, Mayfly allowed us to, it has a very good integration with Jira. So we said we're going to identify each feature with a Jira item. So whenever you start the progress on a feature, Mayfly would create a branch for you, would create an environment where you can test stuff, and would also, whenever there's a new merge into master, will try to replace master within your branch. So it's trying to keep your branch up to date. And anyone that has struggled with Git knows that the best way to prevent conflicts is to keep your branch up to date. And this way, basically, people had a more streamlined way of working. The separate environments actually allowed us to do testing on a feature basis. But, there's a very big but, it's one of the most controversial parts of my presentation, because a lot of people are challenging whether or not you should be using feature branches. And actually, if you look at the paper, in order to resolve this set of issues, they're actually saying that you should do trunk-based development. So for us, this worked very well, but you should keep in mind that it really depends on the people that you work with and the project that you work with. So this worked very well. It did solve our issues, but the recommended way is actually to have no branches whatsoever. Because if everyone works on master, you have a lot less merge issues. The result for us was basically people started having more focus on delivering the features that they have, that they're working on, rather than dealing with all the merge hell that comes with development. So by investing the time in automating a lot of the work for them, they could actually focus now on delivering more. Which, let's face it, every engineer is happy when they can do more of their work rather than dealing with processes. The next problem that we had was the fact that there was no clear visibility on whether or not, or actually on what is going into the release. When we started this, there was, and probably a lot of people from Bol.com even don't know this, but there was a Confluence page where whenever the release is prepared, there would be a git diff, which would be put on that Confluence page as a release change, and then no one would do anything with it. So the moment, that's why a lot of people didn't know that it existed. I learned, I think after 1 year of being at Bol.com, that this thing exists. So the first time someone patches the release because a bug has been introduced, that information is basically useless. And sadly, we didn't have there's no universal solution for this, but for us, something as little as visualizing the git diff in an internal application helped a lot. And I'm not sure if you can see it very well, but basically shows the Jira icon, which, as I mentioned, we use to identify the features. It shows who committed it, and had a reference to the commit and the message. We also had a wall of shame in the beginning for the people that didn't add their Jira items to their commits, but it turns out people didn't really know about it. So when we contacted them, people started adhering to the standards, and we had to make it obsolete because we didn't need it anymore. And to be fair, this was such a success that it grew into something a little bit more. Now, well, at least last time I checked, it was used to verify whether a feature has been verified that it's okay to be released or not. So you could actually see the results of the test suite, which I think in this screenshot has one failing test. And you could also see what are the features that are in the release that is prepared, and you can mark them whether they're ready to be released or not. Which again is one step closer to introducing continuous deployments. Because if your tests are green and your features are verified, you can just move this to automatically to be scheduled for release. A side effect of this, by the way, this dashboard got used a lot by the business people because they could use it to track where their issue is. So instead of coming to us like, hey, where are we going to deploy this? Like, what's the status? They would just ask, like they asked to get permissions for this dashboard, and they would basically see, oh, so this is now on test. Oh, this is now on acceptance. It's going to be in the next release. And if I were in the audience right now, I'd be thinking, oh, these guys, they did everything, fixed all the issues, nailed it. But sadly, it's not the case. We're so focused on fixing the issue. Well, actually, we're so focused on fixing the tests and building the service for pipeline visibility. We actually, when we started releasing more frequently, one of the problems came back to us, and that was the lack of discipline, lack of motivation, and lack of experience. And that was primarily because we failed to communicate very well with absolutely everyone that was working on the web shop that we're going to introduce this new way of working. So the people that knew were really happy with this way of working. The people that didn't know, they were also very happy with this way of working when they found out about it. But before they did, they actually caused us a little bit of problems. And they actually, I think it was one guy just pushing something directly to master, because we still could do that back then, which basically resulted in a lot of issues because we didn't know whether that was very well tested. One of the features of Mayfly, it wouldn't let you merge the issue on your own. When you close the issue, the feature. So when you close the issue, it would merge the branch automatically, only if your tests are good and you're meeting the definition of done. So imagine someone that hasn't gone through all those verifications, just pushes randomly and like, our build is broken, we don't know where the changes are coming, like, who's this guy, why does he commit those things? And actually brought us so much pain that we're that close to rolling back the whole process and going back to the bi-weekly, the releases which were done twice a week. But instead, we managed to push forward and resolve this. We managed to communicate with everyone that this is the way of working. And as I mentioned, people actually liked it more. And we decided to measure whether this was a success or not. So what we measured was that for the first 4 weeks, I think. No, this is 2 months. First 2 months. Instead of having 4 releases, we had 30. And we had released 447 features. And I honestly don't know how many features would have released with the old process, but probably the same. But the fact that we now had the visibility for it, I think is really cool. And the average time for a feature to go to production after it has been completed went down to 4 days versus the previous average of 1.5 weeks. And that is, bear in mind, with that first big glitch with delay, which added a huge delay. So in reality, I think it's more like 2.5 days, Josh? 2 days, yeah. So now we're thinking, this is great. We did a great job, but can we actually make this a little bit better? And we started investigating ways to make the life of the developers even easier. And what we stumbled upon is this blog post by Facebook, which described their release process and basically shows their system. I think it's called Gatekeeper. No, sorry, I forgot the name, but it's basically a feature toggle system which allows them to release all their features behind the switch. And only when the feature has been verified that it works properly, then it's toggled on production. It's a very common technique adopted by not only by Facebook, but by Google, by Slack, and Dropbox as well. And I think right now by Bolt.com as well, because I just talked to my colleague Josh, who continued working on this, and he just confirmed that Bolt has been using this for a few months, really hoping a talk is coming out of it, because feature toggles are a big hit right now, or for a year or so. And for us, it was a little bit of a no-brainer. So we've been doing this for so long. We've been struggling so much with making our releases stable so that we can roll them out faster. But by just putting them behind the switch, you can release almost all your changes with some minimum verification that everything works. Then spend the time to properly test them. Maybe put them behind, I don't know, trigger them on for a specific group which is internal to make sure that it works properly, and then roll it out. So basically, you can have your pipeline continuously delivering code to production, but only enable the things when you're sure that they're working properly. And if you're curious about feature toggles, Martin Fowler again has a very good article which explains what the idea behind it is. He actually has some examples on how to implement it. So if you're curious about this, I highly recommend reading the blog post as well. And now, to wrap it all up, what are the things that we actually learned within this initiative? The first thing is that if you want to adopt continuous delivery on a large legacy monolith or a large legacy system, the first thing that you need is stable and reliable test suite. And the second very important thing to do is to have stable and reliable test suite. I'm serious, you can't imagine how many things this week actually solved for us, because having that confidence in your release is something that you really, really want. And once you have it, you're not going to let it go.
Mike, can you say what tools you use and what this week?
Okay, so it's very important to mention that we're talking about integration tests primarily. So this is not about unit testing. This is primarily about integration testing. Back then, we were using we had a lot of fitness tests, but they were being replaced by WireMock and Cucumber tests. And actually making that change brought down the testing time I think from 2 hours to around half an hour to run the full test suite. So people took the opportunity not just to write new tests, but also to implement them in a new and more modern technologies or more reliable technology. And this is again primarily the functional part of the website.
Yeah.
There's a huge unit test suite, which I think also tests a lot of dead code, but
Probably.
and that's why we actually focused on the integration test, because at least we know how the website should work, and making sure that that part is covered would allow us to easily remove or move parts within the web shop.
Yeah.
So having that sort of protection screen allowed us to change all the ins and outs.
Yeah. Great. Thanks.
The second thing that you need is a proper branching strategy, and as I mentioned, the feature branches work for us, but might not be the best way to go for you. You can also go like full-blown Git flow, but you really have to know that, and it's really important to communicate it well. The second thing is, and I guess this is optional for some projects, but especially if you have a big project, it's very important to have visibility on your pipeline. And to be fair, you'll be surprised how easy you can implement this by just having, using your version control. But the added benefit is just insane, because whenever you have an issue, you can very quickly see what were the changes that could introduce that issue. And first of all, you don't have you have a list, and second of all, because we had that fast release cycle, that list was a lot smaller, so it was really easy to pinpoint what could be the cause of the issue. And finally, you really have to find an effective way to communicate, because even for simple things like the branching strategy, if you're working with a team of, I don't know, 5, max 10 people, you probably see each other on a daily basis and you make that decision together, so it's very easy. But if you have over 70 people working on the same project, you really have to find an effective way to communicate those changes. Otherwise, you end up in a situation like us, where some people are still stuck in the past and are still working with a process that you want to move away from. Now, if you think that took a lot of people and a lot of time, it was primarily the 5 of us. Josh, which is over there, is sitting right behind. He can answer some of the questions as well. And it took us around 4 months to do this as a side project. So we're doing this alongside our day-to-day responsibilities. Of course, we had the support of our managers, and we did spend probably half of our time on this, but it's actually not that difficult if you put your mind to it. And before I ask for questions, I want to mention one more thing which is often missed, and that is the fact that our business stakeholders were extremely happy with this, primarily because having that 2-week cycle, as I mentioned, introduced sort of a mini water flows, and whenever there was a new release prepared, all the business stakeholders was like, but I have this really important feature that needs to be in 2 weeks. But I have this more important feature that has to be put in 2 weeks. And when you tell them, we're not going to work on your feature now, but if I work on it tomorrow, it could be on production, let's say 2 days after, like in 2 days or in 3 days, people are more inclined to be like, oh, okay, I can wait a couple of days. It's not like, that if it doesn't go in now, it's gonna go in 2 weeks. And that actually made them more relaxed in their way of working, and removed some of the pressure from the engineers as well. And with that, I'd like to thank you and see if you have any questions.
Was that something that they were supportive of going into it, or did you have to make a case to do this work before you started on it?
So, I go back. The guy in the middle is one of the guys that sort of instigated this. Well, we all wanted to do it, but he grouped us together. His name is Ruud Traber. I'm not very good with Dutch last names. And he was sort of going into a manager position. And he actually advised us as engineers to come up with a good plan and to present it to the IT management. So once we had a more or less clear idea of why we want to do this and how are we going to do it, it was just a matter of showing them, hey, we're planning to do this. This is how we're going to do it. This is when we plan to do it. And the main feedback that we got was concern, because you know that if we're not releasing every 2 weeks and you introduce like 10 bugs. If you release every day, you're probably gonna release 200 bugs in 2 weeks. Gladly, they didn't react like that, but they were still concerned because the customer impact is huge if you make a mistake. So in the beginning, we're extra cautious. We had some extra testing to make sure that everything's okay and to give them the confidence that this is a good initiative. But it was a matter of just presenting the idea and having a clear goal and a clear path.
One more, if you don't mind.
Yeah.
You mentioned rewriting the whole test suite. You just mentioned some of the tools you used. Did you do any like code generation of tests there, or was that all handwritten tests?
So testing is not my strong suit. As far as I know, actually a lot of tests were reused. So the test, the state of the test wasn't that bad. As I mentioned, there were a lot of people that used it. Actually had an idea how to write the test properly. But as far as I know, there were no generated tests. As far as I know, I think all the tests were written manually.
Thanks.
Apparently you went down from your flaky test suite to only 7 tests, which I'm really scared of.
Yeah.
Doing something huge like this, only 7. That took a lot of courage.
Well, the thing is, those 7 we didn't start releasing with those 7 tests. We just had a tester in the group, and he basically started with building 7 very stable tests which cover very critical functionality, and they were more to set a good example on how this test suite should be expanded. So at the end, I think there are more than 200 tests which were running every time before we started releasing. So in the beginning, we even started doing some dry runs. So we prepare a release, which we never release, but we do all the steps. Like we test them, we test it, we see if the test results come out properly. We test whether the pipeline visibility tool that we use works properly. But again, 7 tests, it sounds scary, but we never planned to go live with just those 7 tests. The idea was to set proper grounds and to set a good example for the other engineers.
Mike, also question.
Yeah.
The team that you see on board right now with 5 people, were they the ones who could make decisions for those 70 developers in terms of the way they were working, or
So,
how did that work?
actually, engineering-wise, the things that we delivered as a group of 5 people were those 7 tests, building the new pipeline which would run those tests and verify everything, and that tool for the visibility. Everything else in terms of processes, we gathered feedback from all the engineers, and at the end we had a session with at least one team member from one team, and we told them this is the plan that this is the way we want to go forward with, and everyone had to say, okay, I give the stamp of approval from my team that we're good to go with more frequent releases. But since everyone was involved in rewriting the tests, everyone was involved in the discussions, we were more, like, you can consider us more as a facilitators, because we had to keep everyone in the room, and we're primarily focused on keeping everyone on track, because that's very difficult when you have meeting with a lot of people, and getting the proper requirements. So the engineering part actually came from the teams, and I think that's the way it should have gone, because we as 5 people simply don't have the time to achieve all of this, let alone the knowledge. Yes?
Which CI/CD tool did you use?
We were using primarily Jenkins. So, pardon?
Are you still using it?
Are we still using it, Patrick? Are you still using it?
Yeah.
Yes, so it's still Jenkins. But I think Patrick has given the talk in this meetup about the flexibility. Basically, there's an abstraction over Jenkins, which lets you define your own pipelines and gives you the ability to define your pipeline as code. And that was the interaction that we had with Jenkins. But we used Jenkins so that's a bit more details, I guess, which are not really about, like, it's an implementation detail, but we ran the test using Jenkins. Deployment was done by Rundeck, which is not a deployment tool, but it's what it was. It's the thing that was used within Bo back then. So it still is, but I think the company is moving away from it. So I think this is the tech stack in terms of CI/CD. Okay. Yes.
When you're talking microservices architecture, how does it change the way you prepare for events like Black Friday or scaling up during that period of time, Black Friday or Cyber Monday?
So your question is about how you prepare about Black Friday and like for basically for the car load in this setup.
Has it become easier when
it makes it easier to have stable releases, and that was our goal. So whenever you have a stable release cycle, this allows you to release regardless of what time of the year is, what day it is. Well, I think it's still safe not to release Friday afternoon before you go home, unless you're working on an application which is only used within business hours. But yeah, having this stable flow actually allows you to deliver new features, basically introduce changes, but primarily deliver new features even in times which you have a lot higher load than usual. Okay, if you have any more questions, I'll be around. So, and you can always hit me up on Twitter. I'll share the slides with Patrick, and as I mentioned, in the last slide you can see all the references about all the articles. That's it. Thanks.